Hello, second grade. It is so good to see you again. Great job comparing lengths for the last couple days. Holy guacamole. That was some great thinking. Today, we're going to continue solving word problems, but we're not going to be comparing today. So take a deep breath. That comparing is hard stuff. So hopefully you've been practicing that in your independent practice and you're getting really good at it. We'll solve some more problems today and tomorrow, but they'll be a little different type of problem. Let's take a peek at our learning target and get started. I can solve word problems involving length. Oh my goodness. Let's go ahead and think about that for a second. When we're solving word problems involving length, that means we are thinking about what we know, what we're trying to find out, but we're thinking about specifically the length of an object, how long it is. So, just like yesterday, I'm going to challenge you all. 1, to think, what do we know? 2, what are we going to try to find out? And 3, what would that equation look like to help me make sense of that problem? That's one of the most important things we can do as mathematicians is make sense of what the problem is asking us. So we don't want to skip that step. We want to make sure we have a space for the unknown so that we know what are we solving for. Let's take a look at our learning target. And I want to remind you that we are solving with different ways. You and the person next to you or the person across the room, you guys might all solve it different ways, and that is okay. That's what makes us all mathematicians, is thinking about ways to solve it differently. And we're going to learn from each other by listening to each other and our strategies, but also thinking a little bit deeper about how our way is similar to theirs and how it might be a little different and help us grow as mathematicians as well. Here's our first problem. Michaela has a string of beads that is 56 centimeters long. Yesterday we did a lot with inches. Today it's centimeters. 56 centimeters long. She cuts off 8 centimeters to make it the right length for a necklace. How long is her string of beads now? Michaela has a string of beads that is 56 centimeters long. She cuts off 8 centimeters to make it the right length for a necklace. How long is her string of beads now? Again, what do we know? Okay, so she has a string of beads. It's 56 centimeters long. What else do we know? She cut off 8 centimeters. What are we trying to find out? How long is her string of beads before or after she cut them off? After. So now how long are they after she cut them off? Can I have you guys all take a minute and write an equation that matches the story? Just one that matches the story. Not one that might help us solve it. What is an equation that will match the story, the actions here? What are we going to start with? 56. And why 56? Okay, that's her string of beads. That's how long it was. Centimeters. Oh my goodness, centimeters long. Okay? What else are we going to do? Why a minus sign? She cut off that amount, right? And how much did she cut off? 8 centimeters. Okay, so she cut off. It was this much. She cut off 8 centimeters. That's that minus 8 equals a box for the unknown. We don't know how long that necklace is now after she cut that off. Go ahead and take a minute and show me how you might solve this on your own. Let's take a peek at how you might solve this work. You may go ahead and begin whenever you're ready. Where are you starting? Are you going to go forward or backwards? Why backwards? You look cold. Okay, you're taking away. Why are you making a jump of 6 if it's minus 8? Oh. Okay. What more? How many more do you need to take off after that? So where is your answer to this problem? Okay, go ahead and circle that. I'm really interested in seeing this. Where are you starting? Okay, and you're not using a number line. What are you using instead? So where is your 8 in your work? Oh, okay. All right, let's go ahead and come together, friends. Let's show that number line first. That number line is really helpful to see. All right, where are you starting on your number line, my love? 56. And why did you start it down here? Because you're going to be going backwards, those smaller numbers, okay? And what did you do first when you made some jumps? Why did you make a jump of 6 if we're taking away 8? Because 6 ones, take away 6 ones equals 0 ones. So it's getting you to a 10. Then what? Why did you take 2 more jumps? Because you're trying to take away 8 total, okay? And where's your 8 in your work? Is it this 8 and 48? This. You're taking my 8. 6, 7, 8. All right, and then where is your answer, or the difference? 48. So you say 56, take away 8 equals 48. I'm seeing some wiggle waggles. Who else used the number line? It's a great tool to use, isn't it? So our answer is going to be a 48 up here. That's not how everybody solved it. I'm really interested in having you share because it's I think it'll bring out some good discussion. Okay, where did you start and what strategy did you use? Okay, so when you use the equations, where did you start? Okay, and what did you do first? Okay, and why did you take away 6? Okay, that got you to 50. And then what did you do? Had 50 and you took away 2. Okay, when you took away 2, what did you find? 50, 49, 48. So you kind of backwards. There's your 1 and 2. And so you had 48 is your answer. Where's your 8 that you took away? Your 6 that you took away first, and then your 2 that you took away. All right, friends, what do you notice about these 2 ways? Okay, so they both made a jump. They both took away 6 first. Why does it make sense to take away 6 first? It gets you to that 10. What else do you notice about these 2 pieces of work? First you took away 2 and then on 48, but they still said 49, 48. This friend went 2 jumps of 1 to get to 48. Same answer. They both subtracted. Could we have written a addition sentence to help us solve this? What would that have been? Okay, so we could have done an addition sentence to help us always start with that 48 plus 8 equals the 56. Let me trace that again. With a marker you can actually see. Would that make sense to have 48 in that box? Should we try it out together? What should I do next? Okay, 2. Why would I do 2? Gets you to 50. All right, and then 50. Trying to add 8. So how much is 2 plus what equals 8? 2 plus 6 equals 56. So here's where you're starting. Here's where you're stopping. And where is that 8? Okay. Does that make sense? Does that work? That 48 would go in this unknown. So that does allow us We could add if we wanted to, but it would make it a little bit more challenging to find that 48 in the first place, wouldn't it? All right, friends. Let's take a minute and read the next problem. I still want to have us writing that equation with the unknown and showing some different ways to make sense of this problem. A path in the park was 22 meters long. Then they added another section of path. Now the path is 50 meters long. How long is the new section? A path in the park was 22 meters long. Then they added another section of path. Now the path is 50 meters long. How long is the new section? What's an equation I can write to match this story? Where are we going to start? Okay. Oh, sorry. Slow me down. We know that the path was 22 meters long. What else do we know? They added another section. We know it's 50 meters long now. What are we trying to find out? How long is that section that we added, right? So now, I'm so sorry. What equation could we write to match this story? What would I write first? 22. Okay, then what? Why are we adding? Okay, we're adding because we got another section. They added another section. What are we going to put after this box, after this plus sign? Yeah, we don't know. We don't know what is going to go in there. We don't know how long it was, do we? It even says, how long is the new section? I don't know. And what can we put after that equal sign? 50, because now it's 50 meters long. Very nice. Go ahead and take a few moments of that private reasoning time to think about how you might go about solving this problem. I bet we'll have a couple different ways this time. Go ahead, you may begin as soon as you're ready. Where are you starting on your number line? Why 22? Okay, because your equation says that. All right, then what are you doing? Jumping to get to what? And why 50? Okay, that's how long it is. So then where is your unknown in your work? Make sure you circle that on your piece of work and put it in the unknown in your box. There's a plus sign up there, but you're subtracting. Where are you starting? Oh, can you do that? What are you taking away? Why are you taking away 28? Because you're stopping at 22. Oh, I see. So you're seeing how many jumps you can make to get to 22. So then, how long was the new path? Is that in your start, your stop, or your jumps? Okay, would you share that with your friends? Okay. Oh, friends, we got lots of good strategies coming out today. I'm excited for this. Okay, let's take a minute. Let's start with the one that matches this equation. Where did you start when you were matching this equation? Okay, then why did you start your 22 down here? Because you're going to bigger numbers. Your bigger numbers go that way on a number line. Okay? All right, then what did you do? Why did you make 2 jumps of 10? Okay, your tens place changed, so you had 32, 42. Okay, then what did you do? Make another jump of 10? Why didn't you make another jump of 10? I would have gotten you to 52. Oh, and that's too far. Okay, so what did you do next? How did you know to jump 8? Oh, because 2 plus 8 equals 10. So 42 plus 8 would get you to 50. Oh, that's so smart. Using those patterns we've already learned. Okay, so then where is your unknown in this work? In your jumps. And how many jumps did you make? 10, 20, 28. And so where's your unknown? So how long is the new section? 28 what? Meters long, right? 22 meters. It was 22 meters long. Then it was 50. We have to add 28 meters. Meters, meters, meters. That standard unit did not change when we were adding it. Even going back here, was 56 centimeters, took away 8 centimeters. So how many centimeters was left? 48 centimeters. Our unit of measure is not going to change when we're adding and subtracting. We have to keep that. They have to keep that the same. Okay, somebody else solved it a different way. I'm very interested in them sharing their strategy. Okay, what did you do first? Okay, use a number line. All right. And where did you start this time? Oh, wait, you started at 50. Why did you start at 50? Okay. Because that's how long it was at the end. Okay, and then what did you do? You jumped 10, 20. And so when you jumped 10, what'd you land on? 40. And then you jumped 10 more, landed on what? 30. What place was changing then? Your 10's place. 50, 40, 30, because you're taking just 10 away. Then what? You're taking away how long it was at the beginning. So you're just taking away 1 and then 2. Okay, and so taking away 1 more was 29. Taking away 2 more was 28. So where is your difference? Where is your new path? So you start with the whole path, take away the old path, and you land on what was left that is building to make the new path. 50, what equation would you write to match that work? 50 minus 22 equals 28 meters. Yes. Oh my goodness, we are on fire. How are these two pieces differently? Differently? How are they different? Oh! Yeah, they're adding. They're subtracting. They both had 22. They both had 50. They both got 28 as the answer. So they're a little similar, little different. How many of you added and followed this same one? Okay. How many would like to try that subtracting to help you solve addition? Okay, so we can learn from how those two are connected. We do have to change the order, don't we? We can't have them in the same order if we are adding or subtracting. All right, let's look at this last one, and then I'll let you guys work on your own. Jude's sunflower grew 8 inches this week. It is 26 inches tall now. How tall was Jude's sunflower at the beginning of the week? First of all, so I don't forget, what is our unit of measure that we're thinking about for this? Inches. Yes, that's our unit of measure. So our answer is going to have what unit of measure? Inches. Yes. Okay, so Jude's sunflower grew 8 inches this week. It's 26 inches tall now. How tall was Jude's sunflower at the beginning of the week? Ooh, what do we know? It grew 8 inches. What else do we know? It's 26 inches tall now. We're trying to find out. How tall was it at the beginning of the week? So where is our unknown going to be in our equation to match this story? Oh, it's going to be at the beginning. We don't know how big it was to start, do we? Our unknown was at the end here. It was in the change here. But it's in the start here. That unknown can be in different spots. What are we going to put after that unknown? Y plus 8. Because it grew 8 inches. Yes. And then what? It equals 26 inches now. So what are we trying to find out? How big it was to start. Show me how you might solve this work. All right. Where are you starting? 8. And what are you going to do from 8? Okay. All right, friends, let's go ahead and share some of these ways. So why are you starting at 8? Because you know 8's part of the your addition sentence. Then what are you going to do next? You're jumping to 26, okay? So you're going to jump 10 to get to 18, okay? Jump 2 more. Why 2? Okay, to get you to 20. And then what? 6 to get you to 26. So you're starting, why did you start with 8 plus something to get to 26? Because you can flip-flop those, right? We can use that to help one addition to help us solve the other one. So what is going to go in your unknown? Where's your answer? How big was it to start? Okay, so we have 10. Well, 6 and 2 is 8. And so 10 and 8 is 18. So you're saying it was 18 inches tall. And 18 can go here. Anybody else solve it that way? Flip-flop those two add-ins, starting with 8 instead of the unknown. We didn't know where to start. We know we can flip-flop those add-ins, and that the answer will be the same. Okay? Somebody else did something a little different. What did you do differently? Why did you start at 26? You can start with the sum and take away one of those add-ins. So remember, the sum is the answer to an addition problem. These two numbers added together equal 26, that sum. But if you start with the sum, you can take away one of those parts. Or you can say start with the whole, you can take away one of those parts. So how do you take away 8? Why 6? Okay, 6 ones, take away 6 ones equals 0 ones and gets you to that 10. Because 10 is a friend, that's right. And then you take away 2 more to make 8. So 6, 7, 8. And what does 20 take away 2? 18. What do you notice? It's the same as that. 18 inches is how long or how tall that sunflower was at the beginning of the story. Second grade, we're going to continue adding and subtracting this afternoon or the rest of the day with your independent practice, reading those problems, writing an equation to match the story, and then you might solve it a different way, right? Oh yes, I'm so glad you told me to do that. These equations are not the same as the equation that matched the story, but the equation that matched the story helps us know how we can go about solving that. Always write that equation with the unknown so that you know how to go about tackling that problem. Remember, what do you know? What are you trying to find out? And how are you going to solve it? Happy solving!